All right, welcome to Unit 1, Lesson 2. We're going to kind of dig into some segments today. So again, one of the things about geometry that we use to kind of measure distances is this thing called the ruler postulate. And so that basically means that you take one of your points and you take where one of your points is and you subtract where the other point is. And when you do that, it will give you the distance in between the two. So again, if we take our 2 points and subtract them, we'll get the distance. Now, we have to use this thing called absolute value, which are these bars, because distances are never negative. So all absolute value means is distance from 0. So if I look at, let's do a number line and let's just say the difference. So here's 0, here's 1, here's 2, here's 0, here's -1, -2. If I look at the point 2 and then the point -2, their distance from 0 is the exact same. They both have a space of 2 units. So the absolute value of 2 is 2. The absolute value of -2 is also 2. Again, distances are never negative. So if we were to look at the ruler postulate, and the question is, how long is this a line or a line segment? This is going to be a line segment because it stops, and because it stops, we can measure it. So I see that L is at about 7.5 and M is at 2. So ML equals the absolute value of 7.5 subtract 2. That's going to be 5.5. And how far away is 5.5 from 0? 5.5 is 5.5. And again, our units, it looks like we are in centimeters. Centimeters. Why don't we put the bar over the ML? Because if we did that, it would be the symbol for line segment, which it is. But again, we wanted absolute value. So building off that ruler postulate is we have segment addition postulate, which basically says if you take AB and you add BC together, you're going to end up with AC. So I can take AB plus BC and it'll equal the entire thing. I like to think about this as little segment plus little segment equals big segment, okay? AB plus BC equals AC. So we can use this to find or to figure out missing information. So if I take little segment FG and I add, so again, that's going to be 15. Let's keep the colors the same. Okay, 15. And I add my other little segment. I don't know what it is. GH. If I don't know what something is, I need to use a variable. So let's just use X. 15 plus X. Little segment plus little segment equals big segment. And the big segment in this case is 36. So we all know how to solve this. Again, this is from algebra. It's just a one-step problem. Anything I do on the left side, I got to do on the right side. If my goal is to get this X by itself, I need to get rid of this 15. So X equals 21. So this GH, so the distance of GH equals 21. Congruent segments. This word congruent means same, okay? So same segments. So if we look, this is a rectangle. So we are saying that AB is equal to DC. Notice this, okay? Right here. No segments. This is because these are distances, okay? So distances can be equal, but shapes are congruent. So this is a line. This is saying line segment. So it's different. Distances are equal. Shapes, which lines are shapes, are congruent. And so we can show that they're congruent by putting a congruent mark. So I can put a dash and I can say AB is congruent to DC. And if I wanted to do that with AD, I can't use just one because that would mean they're all the same. So I can use two dashes to show AD is congruent to BC. So these are kind of congruent symbols can give us information about the problem. Distances are equal, shapes are congruent.